But let's go ahead and get up to the topic at hand. What is a capacitor? And what does the capacitor do? And where is the capacitor located? Well, simply, your capacitor is located on the outside condensing unit, and it's part of the functionality of the operation for the compressor. And if it's a dual or what they call a split or a dual, it actually has a multifunction, and we're going to get into that. So let's go ahead and take a look and see what is a capacitor and what it does for the system and what the importance is for it and what you can do as a homeowner to maintain those kind of parts, especially if you're capable of changing them yourself. So, what is a capacitor? Simply, in an HVAC system, the dual run capacitor is connected to both the compressor motor and the fan motor. It provides a necessary electrical boost during startup for both motors and also ensures that the continuous operation of the fan motor. The capacitance value of the dual run capacitor is typically marked on its label, specifying two capacitance ratings. For example, it might read 40 plus 5. So it's read, and when you do a reading, it's in microfarads. That's how actually a capacitor. So on a dual, when you get one, say it says 45, 440, that's 40 for your compressor, 5 that's rated for your fan, if that's what the fan motor on the condensing unit is requiring, and then the voltage on it. Sometimes you might say 45 370 or 45 440, and that's kind of the rating. So that indicates that it has a capacitance of 40 microfarads for the compressor motor and 5 microfarads for the fan motor. By using a dual run capacitor, the HVAC system can reduce the number of individual capacitors needed, and it simplifies the wiring and installation process. It is important to note that dual run capacitors, like any other capacitors, can degrade or fall over time and may need to be replaced if they become faulty. And there are two types of ways, and I will actually show you pictures of two forms of how you can actually set up a capacitor, especially if you don't have a dual in your truck or you want to separate the two, or another scenario, say your condenser fan motor goes out and you place it with a universal. Well, the universal will have two brown wires, one brown wire that's solid, one brown wire that has a solid with a white stripe, and they're both connected to the capacitor. There's a way to eliminate one of those, but under a homeowner, I wouldn't do that unless you actually knew what you're doing. I would follow the proper procedures on the installation. So here's a picture on the left of a dual capacitor, which has on the markings on top of it will say fan, common, and hermetic. Basically, fan side goes to the fan. That'll be the brown wire. Hermetic side, sometimes it's yellow. It could be orange. It could be a different color. Common side usually is black. And then on the right side is a single capacitor. That means I'll give you an example, and then we'll show you a picture. Say one of those is 25 440. So that's for the compressor because of the high rating of the microfarads. And one side will go to the compressor side, hermetic side. The other side will come from one source, usually the common side of the contactor, to pull it over on top of it to feed it power. Otherwise, it's not going to work. So it's a little bit more complicated, but it still runs under the same thing. If you look at a split, that common side that feeds in is what's actually powering that capacitor. So that's a dual, and then those are singles. Duals always have 3 prongs on them. A single only has 2. So let's look into it. It says an HVAC capacitor, also known as what they call a run capacitor, is an essential component to the heating, ventilation, and air conditioning system or HVAC system. It is an electrical device that stores and releases electrical energy to help start and run the motors for various HVAC equipment such as air conditioners, heat pumps, and blower fans. Capacitors are a passive electronic component that stores electrical charge in an HVAC system. Capacitors are typically used in conjunction with motors that require an extra surge of electrical power during startup. When the HVAC system is turned on, the capacitor provides that additional burst of energy to help the motor overcome inertia beginning its rotation. So basically, What a lot of times I'll do is when I go out and I want to check a capacitor, I'm going to de-energize it by basically I'll take my meter, I'll go across it one way, and then I'll go across it again to de-energize the capacitor. I don't want that energy in there. And then I'll go and I can check how to test the capacitor. And testing that one there, if it's a dual, we will go into the testing of that later. This is just basically going over what it does to the system, what it looks like, and where it appears on your outside condensing unit. And the other one, we'll go over the testing part of it and how to test it on your meter, and I'll show you exactly how to do that. So let's go ahead and take a look. This is a separation where instead of running a dual capacitor, you're running two singles. So the first one that you see the arrow going to, that is for the fan. And as if you notice, the size difference is there as well. The fans are usually, 5, 7.5, 10, sometimes 15. On the compressor, you'll see them running from 20, 25, 30, 40, 55, 75. They can go even higher. Just depends on the capacitance for the reading for that compressor and what is used for it. Now, there is one thing I can always tell you. I'll give you an example. If I go out and say, for whatever reason, the capacitor has failed, and say it was a 35.5 440 that was on it, but I go back to my truck and all I have is a 45 440. You can go up 5 microfarads and use that capacitor in replace of that 35. 5 microfarads is the maximum upgrade limitation that you can. So if it's a 30, you can use a 35. If it's a 40, you can use a 45. If it's a 35, you can use a 40 if you have to. I like to replace it with the original ones, but you can go up 5% and be in the safe zone for that split. As long as you're not changing the capacitance for the fan, it has to stay the same for the fan, but you can go up 5 on the compressor side of it. Like I said, there are two types of capacitors used in an HVAC system. One is a start capacitor. This capacitor provides the initial electrical boost to start the motor. It is designed to provide high level of capacitance for a brief period, and then it disconnects from the circuit once the motor reaches its operation speed. Now, you'll hear people make a statement, hey, I'm going to put a boost kit on or a start kit on it. Okay. A start kit is basically a relay and a start capacitor that comes together. And it actually gives an initial boost for that compressor, especially if you have a compressor when it's going into operation and you want to do, they have lock rotor amps on it, and it has a maximum range. If it reaches the lock rotor amps, that compressor can kick out. If you're getting close to that and you want to keep that load down, you can put a start capacitor on it, and it will reduce the load on that compressor and give that compressor a little bit more life to it, until the time comes that you either want to change the compressor or you just do a complete change out on the condensing unit. Now, the run capacitor is the one that you've been seeing, and the capacitor is continuously connected to the motor circuit during its operation. It helps maintain consistent voltage and provides ongoing electrical support to the motor. So you have the start capacitor with a relay. As soon as it boosts and starts ramping and it reaches its maximum load to run, the start capacitor will kick out, the relay kicks itself out, and the run capacitor is now taking over and doing its job. Same thing with a run capacitor for the fan motor. It does the same thing. They're both ideal. The blower motor that you have on your indoor unit, it has a capacitor as well, and you'll see it mounted to the outside of the squirrel cage. Now, capacitors can degrade or fall over time due to various factors such as age, voltage spikes, temperature fluctuations, manufacturer defects. When a capacitor fails, it may lead to a motor malfunction or prevent the motor from starting altogether. In such cases, a faulty capacitor needs to be identified and replaced by a qualified HVAC technician to ensure the proper functioning of the system. Let's go ahead and take a look. These are two pictures of HVAC capacitors that have fallen. Now, if you look on the one that says a good capacitor, that's what a capacitor should look like on normal operation, brand new. The one on the right is a swollen. We call it a mushroom. It actually forms a mushroom head on it, and it has failed. The fluid in it has burst in fluid and it has swollen the capacitor and it has failed. So that means it's not operating for either the fan or the capacitor. Now I have gone out and found them swollen where it's still running. I don't know how, but it's still running on the fan side, but it's not running on the compressor side. And then the one on the right hand side shows somebody changing a dual capacitor out for a new one. It probably had fallen or is below the ratings on it. So say the fan side, instead of rating 5 microfarads, it's reading 4.1, 4.2. Well, it's time to change it. It's time to give it its rating because eventually it's going to fail and the fan's going to quit working on it. And that's kind of how those things function. They're real simple, but they provide a significant value to your HVAC system. They're not real hard. They're real easy to change. But remember, I always told you, there's a disconnect on the side of every unit. It has to be out there by city code. That's a preventative measure to protect the service tech so that he can actually do service on it, or if the homeowner needs to do service on it. But always remember, safety first. If you're going to go out there and do anything and you're going to go take a look at it, even if you're going to take that panel off, turn the power off on the disconnect before taking that panel off if you want to go out there and look at your system. I always encourage homeowners to go out and look at it, but make sure you turn the power off, because if you stick your finger in there, 220 volts will really give you a zap. I've been hit by it myself, and I'm a professional tech, and incidences happen even when you're doing a charge up. You have to be really within your system, but sometimes you get yourself in a little bit of hurry. Getting zapped by that is not a fun thing. I've had it where it's just actually made my arm hurt like crazy for up to 5 minutes after getting hit, and I got to sit there and calm down. But make sure you turn your power off. Well, guys, that's it. If you have any questions or anything, leave a comment down below, and I can answer those questions for you. If you're new, subscribe to the channel. Hit the like button. Hit that subscribe button. Hit the thumbs up button, guys, for me. That really helps out the algorithm. It allows this video to get out to more people so that the algorithm can pick it up and put it out there more so that people can learn. The whole platform here at HVAC Beginners is to get out to that homeowner, or maybe that specific person that's really thinking about becoming a service tech and kind of want to get a feel for what's going on out there before he decides to commit to going to school and making that his career, especially you young people out there. So with that, guys, I hope you enjoyed it. This is what a capacitor actually is. This is what it does for the system. We'll see you on the next video.